Okay, so the first big question is, why do you keep coming back to the OpenStack Summit?
Because OpenStack is f***ing awesome.
The OpenStack Summit is really unique because the entire community comes together from all over the world. People from 60 countries, people from hundreds of companies, and they come together to collaborate about what to build in OpenStack, how to deploy it, and where we need to take the software in the community.
Upstream Institute is the basics that someone needs to know when it comes to participate in the OpenStack community. They are learning how the different tools are working, what are the best practices of using these tools, and how an open source community works, even if they don't have experience with open source from earlier.
The marketplace is like a showcase. It showcases the people who are working on OpenStack. You can walk around the different vendor booths and try to figure out what products they sell, and you can have interactive conversation with the people there about your own experiences, how you have your own clouds or how you can use their products in your cloud and things like that.
The forum is where we discuss the future of the OpenStack software in a cross-community manner. We don't do design behind closed doors. We're really into including as many people as we can, and the forum is where we achieve that promise.
Yeah, essentially we used to have two separate events for developers and operators called the Ops Summit and the Design Summit. And the forum, is basically a way of us fulfilling our role of ensuring communication is happening between all involved parties.
If you work on a project just inside your company, everyone kind of thinks the same way, but when you come to an OpenStack Summit, you may build for one use case, and then someone shows up and say, hey, we use that for something completely different. It's so awesome to be able to hear that not only your stuff is being used, but that it's being used for a use case you never thought about.
There are very few women that are in technology in general, and there are even less Black women. To know that we're out there and that we're into seriously technical things, it's empowering.
So Women of OpenStack is our advocacy group for women and their allies to come in, to meet, to network. Throughout the summit week, they'll be telling you woo's here, woo's there, to find the resources and feel empowered to stay in the community and keep contributing.
That's a lot of woo.
I barely use my laptop when I'm at the summit. That's not what I'm there for. If I'm in the design session and I need to code something, well, I'll find a moment and I'll just 1 hour, whatever, and do whatever I have to do on my laptop. But I spend most of my time talking to people.
Whenever it comes to deciding whether I will talk to someone or attend a session, I usually talk to someone.
Don't take your computer. Take some paper, some pen, take notes, but don't spend time on your emails and stuff. Focus your few days on talking with people and working with them.
Software is hard, and if you get to know the people, then software becomes easier. This is a place where there are many people who are like you, so get to know people, build your network, and make friends.
Good morning, OpenStack. Welcome to Sydney. Please welcome the founders of the Australian OpenStack user group, Tristan Good and Tom Fifield.
Welcome to Australia's first ever OpenStack Summit.
Please allow me to acknowledge the Aboriginal and Torres Strait Islanders as the people who are the traditional custodians of this land upon which we hold our event.
So back in 2011, within a few days of each other, we independently had the same idea, to start an OpenStack user group in Australia.
Yeah, and the first meetup we had was in a pub under the Sydney Harbour Bridge. And we had about 30 people turn up. And now, look, we're in this shiny new convention centre.
It's fantastic. And over those 6 years, a great deal has happened. OpenStack has gone from being a literal science experiment across Australia's universities to being an important part of the infrastructure at all major telcos, most major banks, and several pretty important government departments. So, Tristan, you've been working on bringing the summit here for 6 years. How are you feeling today?
We started working to get the summit here in San Diego, so I'm really, really pleased. And over the last 6 years, we've held about 100 meetups around the country, and they've grown from being, drinks in a pub and pizza, and to OpenStack days where we've had several hundred people come along.
That's true, and I think some of our friends from overseas might not be aware. Australia's pretty vast, and the Australian group is quite unique in terms of its reach.
It is quite unique. Many of the other groups are city-based, but our group expands across the whole country.
And we were chatting at the pub last night, as
As we
Aussies
do, yeah.
and just
I don't remember much of it, though.
Yeah, talking about the Australians tend to have a pretty good presence at OpenStack summits.
Yeah.
So I wonder if we've got any Australians here. Should we?
I don't know.
Do
Yeah,
a
I think
traditional
so.
call out?
I think so.
Aussie, Aussie, Aussie! Fantastic. So, a really important part of OpenStack's growth has been its global adoption. And it's so fantastic to see, in addition to the Aussies here, we've got people from all around the world. We've got major sponsors, contributors, board members. Welcome everyone from the Asia-Pacific region in particular, which has exploded over the past couple of years. And a globally engaged community is critical for OpenStack's success. We're very excited to bring you here to Sydney to sample some of the finest. Hang on, this says the food in Sydney is the best. I'm from Melbourne, I can't say that.
I know we've got the Melbourne weather at the moment.
Ah, okay, we'll stop that. Anyway, Tristan, you've been running a company here in Australia from the beginning. I think you want to give a quick spiel about
so
that.
that's my day job. I'm CEO of a company called Aptera, and we're a consulting and managed services company that's specialized in OpenStack for most of the time that OpenStack has been around. So you're probably wondering about the astronauts. Well, we're not actually astronauts, we're solutionauts. So we're a little different to most other companies. We don't do product. What we do is we work with our customers doing services, and we work with many of the vendors in the OpenStack ecosystem, and that's led to us being known as a trusted advisor for many of the largest organizations in the country. We go far beyond what regular services consultants might do, as you can see. And we're good at it. Just ask any of them. Come and see us in our booth in A3. So enjoy your stay, beware of the drop bears.
And the bastard kangaroos.
And don't feed the bin chickens.
Let's please welcome Mark Collier and Lauren Sell from the OpenStack Foundation.
All right. Thank you, Tom and Tristan, and the whole Aptera team, and everybody who's helped build the community here in Australia. And I can't believe we're here at our 16th OpenStack Summit. Absolutely amazing what this community's been doing over the last few years. And it's the first time we've been to Australia, so this is an exciting opportunity for us.
It is. So Mark and I will be your MCs for today. We have a lot of great content for you this morning. We're going to talk a little about the future of OpenStack and open infrastructure. We're going to hear from a lot of users, and then we're going to hear a little bit about some scientific research that's happening on OpenStack, and there will be some cute animal pictures, so definitely want to stay around for that.
Do not miss the cute animals.
So a little housekeeping before we get started. There's an insert in your badge. On that, there's the Wi-Fi password. There's also a map for the venue. You came into this theater on the 3rd floor, and if you go down 1 floor, on the 2nd floor is where there's the expo hall and lunch and most of the breakout sessions. And then up on the 4th floor, you'll find the forum, which are having the collaborative working sessions and working group meetings and those type of content. So tonight, we hope you will join us at the Marketplace Mixer. We're going to have a DJ, some surprise entertainment. And if you came with a travel buddy or want to bring a spouse or friend, you're welcome to bring a +1. So please join us for that tonight. And then tomorrow, we will be celebrating the Melbourne Cup.
What's the Melbourne Cup?
It's a pretty big deal here.
Oh.
It's a horse race.
Okay.
So we're going to be streaming it live in the expo hall. We're going to have some ice cream. It should be a good local experience. So come check it out.
If you like horses or ice cream, this is where you want to be. Open source is all about feedback and participation. So tell us how we're doing. There's a couple of different things to remind you of. One is we have a survey, just 3 questions, about the summit overall. So you can fill it out when you're having that free ice cream or any other time, depending on how you feel we're doing. But please fill that out. Here's the URL. Now we also have an app that hopefully you all have on your phones already, the OpenStack Summit app, and in that app, you can actually rate every single individual breakout session. So those are 2 ways you can provide feedback and participate and make sure we keep improving the summits every time. Now, one thing we could not, definitely could not pull off a summit of this magnitude without our sponsors. So I want to thank all of our sponsors. Make sure you get to know all the people from these companies. A lot of them will be speaking this morning and throughout the week. And of course, they'll be in the marketplace for the Marketplace Mixer tonight. So I hope to see all of you there. I also want to thank everyone who supported our travel support program. Individuals and Verizon as a company all pitched in so we could bring 30 additional people here that otherwise couldn't be at the summit. This is really important, so thank you to all these people, including Lauren. I see your name on there.
Yes.
Who actually support this program.
It's easy to donate. Chip in next time.
Yep.
So I guess about 40% of you that are here today are at an OpenStack Summit for the first time. So just want to quickly give a little background and overview about OpenStack. We are a community of thousands of people over the world, including developers who are building software that automates infrastructure resources like computing, storage, and networking. So that software is available under an open source license, and it's also available from a large ecosystem that has private cloud solutions as well as offers public clouds, and you can find those in the OpenStack marketplace. So one of the things that we do at the foundation is we actually test these products and services to make sure that they're interoperable. And to know if a product has passed those interoperability tests, you can see this OpenStack-powered logo. And those tests have continued to get more robust over time. So today we wanted to recognize the companies who have passed the latest round of tests and are continuing to work to make their products interoperable. So thank you to them.
Yeah, and I think, Lauren, you mentioned that you can get OpenStack in a lot of different ways from different companies and delivery models, public and private cloud. And I think it's no secret that OpenStack is really the de facto standard for private cloud, but a lot of people do not realize just how big the footprint is of public clouds powered by OpenStack. And I love maps, so I thought I would put it on a map here. So these are all of the regions, different data centers, over 60 different data centers all over the world that are powered by OpenStack public clouds. A lot of people, I think, have kind of written this off or don't realize just how big the footprint is when you combine all of these awesome companies. Many of them are here this week, and you can get to know them. And even just in 2017, a number of new regions were added. So we've been able to continue to expand as an ecosystem and as a community the ways you can get OpenStack. Some of the companies that have added capacity and new regions this year are Telefonica, OVH, which added a new region in Poland, Vscaler, Memset, and City Network, which has been very active in growing their footprint. They recently opened a new data center in Dubai. So OpenStack is all over the world, not just in private, but also public cloud form. And if you want to try it out, we've tried to come up with a way to make this a little easier and more accessible. So we have, starting this week, openstack.org/passport. What that is a place where you can find all of the public cloud providers powered by OpenStack that offer free trials. So it's one place you can go, and I want to also just acknowledge the Public Cloud Working Group. We have a lot of working groups that get together for different special interests across the OpenStack community, but the Public Cloud Working Group has put a lot of effort into this. They're also looking at future capabilities to bring on more and more capabilities so that you can easily move between OpenStack clouds. And today we're starting by sharing this page where you can go and find out where you can tap into public clouds anywhere in the world. Now, since we've blanketed the planet with OpenStack clouds, what are you going to do with it? Well, there's a lot of different use cases, obviously, and to tell us about one of them is one of the biggest OpenStack public cloud users that I know, Monty Taylor. So come on out, Monty.
Hey, Mark.
All right.
How you doing? I thought we were shaking hands.
The Monty Taylor.
Oh, the Monty Taylor.
Okay,
scary.
Monty, so I know you've done a lot of things to use public clouds with OpenStack, but one of them is a tool that's been developed in the OpenStack community called Zool.
That's right.
So tell us what Zool is.
Zool is a project gating system. So it's the thing that allows us to fully integration test all of the changes that the thousands of OpenStack developers submit from all over the world.
Okay, and so would you say it's a CI/CD type
It is,
system?
yeah. It basically sits in between changes that people want to make to OpenStack and those actually winding up in the finished products. It allows us to ensure that they're good, that they work, and that all of everybody's changes work together.
Cool, so this is one of those tools that's been developed in the OpenStack community that many of you may not be aware of. And I think you're making some efforts to make it more accessible even outside of OpenStack with version 3. So what's new in V3?
So V3, you mentioned one of the most important things about V3. We designed it actually from the beginning to be runnable by other people. So up until now, Zool is a thing that we wrote for ourselves to solve our own problems. And with V3, we've changed that a bit, and it's explicitly now designed for other people. We've also added in some really important capabilities, especially for OpenStack, but for other people as well, such as multi-node testing. So that's a native feature. You don't have to do weird hacky things. You can actually just say, hey, I need to test a 10-node cloud, and Zool will very happily say, sure, that's easy to do. And finally, we ripped out a lot of the back-end guts, and people now write their job content in Ansible, which is an actual tool that people use to do deployments rather than some sort of testing-specific automation framework. So we're really excited about all those things.
And I believe you actually even had a community member participate and contribute GitHub support.
Oh yeah,
so that's a pretty big deal.
We've added all sorts of things. One of the really cool things in V3 is we've added a bunch of modularity and pluggability. GitHub support is one of the things that we added. We don't really use GitHub for OpenStack development, but other people do. So with V3, we want to support that. We've got support for other ways of getting nodes and all sorts of stuff like that. So it's really exciting.
Very cool. Well, I encourage all of you to learn more about Zool. It is one of the most innovative projects to come out of the OpenStack community. And I believe there are a few opportunities where people can meet you and the rest of the Zool team.
Yeah, it turns out it's actually more the rest of the team than me. I'm just the pretty face. We got 3 sessions going on this week about Zool. 2 of them, I think Paul Belanger is leading. So he's really going to be the face of Zool this week. I think that's the first and third listed there on the slide. And the second one there in the middle, Clark Boylan is leading. And it's a feedback session. We just rolled out version 3 over the last few weeks to the OpenStack community. And so we're going to be leading a feedback session to hear from people what worked, what didn't work, what do we need to do moving forward to support our users.
Very cool. Well, thank you for giving us a real concrete example of what you can do with a huge network of clouds. I believe you actually tap into 8 or 10 different clouds right now. With,
one of the great things that you were mentioning, the interoperability programs and everything. Because of all of those public clouds are interoperable, we're able to treat multiple regions of multiple clouds as one big giant cloud from our perspective. So if one of them goes away or one of them has a little bit of a glitch, our users don't have to experience that problem.
Very cool. Very cool. Well, next up, to tell us about his vision for the future of open infrastructure, I'm excited to bring out our Executive Director, Jonathan Bryce.
Good day, sir.
Well, thank you, Mark and Lauren and Monty, and good morning, everyone. Welcome to Sydney. We already did an Aussie call out. I'm curious, how many of you are here in Australia for the first time? Wow, that is a lot. That's really cool. Well, I'm glad that you endured the long flights to get here. It's a beautiful country, and Sydney is a great city. And I know the weather is a little rainy today, but it's supposed to clear up through the week. So I hope that all of you get a chance to go stack outside some this week and see the sights here in Sydney. So Mark and Lauren, they started out talking about how this is our 16th OpenStack Summit. And that is that's kind of crazy to think about. We've spent some time talking about where we've been, how we got started, where we've come from. And I wanted to start with a little bit of that this morning. This is a very early photo. This was actually the first OpenStack trip outside of the US. This was in the end of October of 2010. And this particular photo is from Japan. And Mark and I definitely look a little different now. We're going to have 100% fewer suits on stage today, no suits. But it was a really exciting time as we were starting OpenStack and building a community. And that has been an awesome journey to be on. One of the things that we haven't really talked about through that process is kind of the name of OpenStack itself. And I think that the name actually does a pretty good job of symbolizing how unique this community is and what we do and our approach to it. And it can mean a lot of things to different people. Open and stack are words that people interpret differently, and they interpret them in the context of our brand differently. But for me, when I think about this, I actually see kind of two parts that are key attributes for what we're doing. The first part is, what is the activity that we take on in our community? We're building a technology stack, but it's not a rigid stack. It's not a single approach to doing things. It's actually a flexible, programmable infrastructure technology stack. But just as important as that is how we do it. And open is one of those words that people use all of the times in a lot of different ways. But for us, in our community, we have a specific set of philosophies that define what open means to us. We call it the 4 opens. And it's how we write our code, how we design our systems, how we manage our development process, and how we interact as a community. And when I think about those parts of what we are, to me, the technology is not the most important piece of what we have created. I think that the best thing that we've created is actually this community. And it's a big community, 82,000 people in 187 countries. And we get together a lot. Every year we have about 20 to 25,000 people that come to OpenStack events to work on these different issues that we face, to go after our goals of building open infrastructure. And this is one of those big events here in Sydney this week. But when I think back to that photo, that much younger photo in Japan, the reality is that none of us knew where this would go. But one of the great things is when you build a community and you base it on principles of openness and collaboration, not knowing where it's going is actually a huge benefit. Because what it means is that the community as a whole gets to define that. So if we think about where we started out in 2010, we had just a couple of projects and some ideas for use cases. But in the time since then, when we fast forward to today, we see that this community has created incredible diversity, not only in just what we've built, but also how it's being used. We started out with a lot of IT companies. As Lauren mentioned, we've seen a lot of growth in the users that we're going to be hearing from this week. And for instance, it's companies like Pacific Textiles. This is a fabric manufacturing company that makes the fabric for major brands all over the world, like H&M. In Boston, we heard from GE Digital Healthcare, who is modernizing the approach of diagnosing and managing medical records. And they're doing that with cloud tools, including OpenStack. And one of my favorite new use cases that I've learned about this year is actually the China Railway Corporation. And we have some representatives from the China Railway Corporation who have joined us. But this is really, when you think about it, railroads are kind of the original infrastructure as a service. They are a critical piece of connecting our societies, transporting goods, moving people around. And the China Railway Corporation is the largest rail company in history. And they use OpenStack to power their production IT systems, to power their passenger ticketing systems, to manage freight, to manage the thousands, hundreds, over 100,000 kilometers of track in China. This is an incredible use case that back in 2010, we weren't really thinking that someday the trains might also run on OpenStack. And when we look at the technology, it's gone from those 2 initial projects, Nova and Swift, to manage just virtual machines and object storage, to an array of services that bring together bare metal, containers, virtual machines, different kinds of storage environments, different software-defined networking. And that's been, again, driven because we built an open community that helps to drive us in the direction that we need to go. Every 6 months, we do a user survey. And one of the really interesting stats in our most recent user survey was the usage of Ironic in production. Ironic is the bare metal provisioning service for OpenStack. And in the last 6 months, Ironic usage in production has gone from being active in 9% of OpenStack environments to 20% of OpenStack environments. That is a huge growth. And that's the kind of thing that I love to see, where we build a tool, the community helps us refine it, and then we see massive usage of it that drives all kinds of new use cases and new production workloads. The other thing that we're seeing is that not only are we getting new services inside of the data center, but we're really changing the definition of cloud. And we're taking it outside of the data center. We're moving it into all kinds of places that you wouldn't necessarily have thought of running cloud even just a couple of years ago. We see OpenStack environments in coffee shops and retail stores, out on the edge of telecom networks, and just an increasing diversity in how these services are used and the tools that people combine with them. A really, really good example of this, I think, is eBay. To me, they're one of the best examples of a company who has really taken advantage of the transformation that's been happening in the technology industry and done it with open source technologies. So this is Sunit Nadwani. He spoke in the Boston Summit as well, and he talked about eBay's journey and some of the tools that they use. But they've gone from an environment that was a fairly traditional VM-based environment to an environment that still includes thousands and thousands of virtual machines, but it also includes a very large array of bare metal physical servers, of containers with technologies like Kubernetes integrated into them. This year, they also have launched a GPU-based machine learning platform for their team. And so they have built out a really powerful set of services using open source tools. And as I think about our history and these use cases, I feel like we are really collectively answering one of those age-old questions in open source. People often say, is open source destined to just be a fast follower of other companies, or can open source innovate? And when you look at these kinds of use cases and you look at what people are building in the open, the answer is definitely yes. Open source can absolutely innovate. But I also think that yes comes with an asterisk, because we are great at innovating, and we're great at creating new technology for specific uses. But in reality, users don't need a virtual machine. They don't need a container. They don't need a network. Those are the tools that they use to build services that route phone calls, like AT&T, or that move money, like China Union Pay, or that help prevent identity theft, like Commonwealth Bank. And overall, what we're trying to do is we're trying to make better decisions and help our businesses run better. And that's not about just technology. That's about putting technology into production in the real world and solving problems. And to do that, innovation alone is not enough. And when I look at our user base and I have conversations with them, they see all this innovation that's happening in open source, and they think that it's amazing, and they want to take advantage of it. But we have an integration problem in the open source community. And this is preventing users from being able to capture all of the value from our innovative projects. And so this is something that we've been thinking a lot about in the OpenStack community. And we have put some effort into trying to evaluate what is our role in this and what should we be doing. And that's been something that we've done as a community this year. And one of the people who has helped us with that is somebody who's a board member at OpenStack Foundation and also an open source leader in a number of communities. And I want to bring her out to help us talk about this now. So please welcome Allison Randall. Welcome, Allison. Thank you for joining us.
Thank you.
So, we've been talking about this integration challenge, and you've really helped us this year think about what we should be doing as an OpenStack community to work on this.
So what does it take to tackle the integration of open infrastructure? Why do we think that we'd be good at this even? Over the past year, we've been working on a series of strategic exercises with the board, the technical committee, the user committee, and talking with our users, really exploring who we are and where we came from and where we're going. And as part of this, we've highlighted some of the strengths of the OpenStack community. And one of these is a strong model of collaboration across the community. And this is both internally, because we're structured as a collection of projects who work together to define the big picture and plan out the work for each release. but also externally. You know, if you look back over the history of OpenStack, we have always been about collaborating with other open source projects. From the early days even, you know, around compute, networking, and storage, you know, Linux distributions and virtualization projects and things like that. Another of our strengths is that we have an open model of self-governance. And this allows communities of collaborators to adapt over time to new situations, new challenges, new opportunities. We have an approach to evolving infrastructure that has allowed us to approach new technologies and integrate those into our existing infrastructure to address new use cases and new user needs. And then we have an approach to development that is specifically a group of semi-independent projects with strong integration points that are well tested together and that work well together. So from the beginning, we have looked at OpenStack as a kind of an integration engine. Now, in the early days, we really only saw that as an integration of a software platform for compute, networking, and storage, with a consistent set of programmable APIs for accessing those resources. But really, infrastructure is much bigger than just OpenStack. It's a collection of technologies, and our users are combining those technologies together in many different interesting ways to meet their use cases. But really, it's even bigger than just integrating technologies, because what we're talking about here is integrating knowledge across multiple different communities and working together to create well-integrated solutions that meet the user's needs.
And for me, this is something that is another part of the DNA of our community, and that's that, you know, we've often said we fight for the users. And I think about users like eBay, who are integrating all of these technologies. And if you talk to their teams, they've had to build quite a number of tools in order to make these open source technologies work together. AT&T is going to speak in a second, and they're going to talk about some of the tools that they've had to build to make all of these open source technologies work together. So when we talk about integration and we talk about how that's a very user-driven activity, this is something that is coming directly from our community right now. And they want to be able to do this in the open and collaboratively. They want to go after those glue pieces and build them together. And so one of the things that we've done as we've kind of been planning for the next few years is we've identified 4 steps that are absolutely critical for integration. And this is kind of the minimum set of requirements that you really need to have solid integrations. So we're going to start to work on this as a community and as a foundation to align our activities around these 4 steps. And if you think about it, the first step, pretty obvious. You've got to find a common use case, a reason to do the integration. And sometimes, you know, in the open source world, we show slides like this that have a bunch of open source logos on them. But in a way, that's a little bit of the problem, because this does not make them work together. When we look at those use cases from users like eBay and Yahoo Japan and FICO and JD.com, these are companies who are taking those logos and having to do a lot of work in order to make them function together. Again, back to our user survey, in the most recent data, we asked the question, what tools are you using to manage applications on top of OpenStack in your environment? And you'll see that there are a lot of different open source tools that people use. Kubernetes is an extremely popular example. But again, you go to these organizations, and how do they manage the networking, the security, the identity, and tie that into all of the systems in their business? It often takes some extra effort. And that's just the work that people are doing today. Within our community, we also have people who are building the platforms of the future. Edge computing is a very exciting, emerging area. SDX Central did a survey just a couple of months ago, and they asked people, what technologies will you use to manage your edge platforms? And 87% of them said OpenStack. But you know, when you look at this, the thing that is most striking to me is how many open source tools are involved in this. So you know, these people are planning to build production edge environments using a whole set of open source tools. We've got to make sure that they work well together.
And once you have defined those use cases, then you have to start bringing the communities together. You have to build trust across communities and deliver standard interfaces that you can count on when you're integrating the components. So interoperability efforts are really key to making sure that these integrations are repeatable, stable, and production quality. One great example of the kind of work that the OpenStack Foundation has been doing in this is the Open Dev event that the foundation organized in San Francisco. Now, this was not an OpenStack event, although it did involve a lot of OpenStack people. It also involved other open source communities coming together to talk specifically about edge computing in this case. And the great thing about that event is it wasn't just talk, it wasn't just slideware, it was really practical sessions, really practical developers getting together and exploring the technologies that we have that are the pieces of edge computing and the gaps between them that right now are blocking us from making a really great integrated solution. And then even strategizing around, okay, what are the next steps? How are we going to develop the rest of it?
And events like this, I think, are something that we need to see more and more of in the industry. And if you look at the OpenStack Summit specifically, you'll notice that we have a growing number of open source technologies that we feature and we provide space for because, again, our user community is interacting with all of these already. And so after you've found the use cases, started the collaboration, a lot of times what you'll find is that there may be some gaps that exist. And so you have to decide how you're going to fill those gaps. When you look at OpenStack, we started with a couple of very small projects in the beginning, and eventually we expanded that over a number of services. And we added services to do orchestration, to do monitoring, to enable connections to adjacent communities, like the container communities and the deployment tool communities. But ultimately, all of these other tools are built around a common core that's the key functionality that's in every OpenStack cloud and the foundation for that. And those are on this map. Those are the core projects are the one in bold. And we have to really make sure that as we identify other areas to go after, we keep in mind what those core services are. Those are the foundation of it. But when we talk about edge computing, like we did at the Open Dev event, it was interesting because we identified things that are needed in order to do a real edge deployment. Those shouldn't necessarily go into this OpenStack core. Those should be built by edge experts and integrate very well, but not necessarily try to fit them into the core of OpenStack and dilute the meaning of that. So when we look at some real-world examples of what we're talking about, I think lifecycle management is an interesting space right now. In the OpenStack community, we've had a number of approaches to this, tools like OOO, OpenStack Ansible. Some new container-based ones that have come out in the last couple of years include Cola and OpenStack Helm. And we're going to see an OpenStack Helm demo in just a little bit. But that's one thing. And in our community, we see so many new things. We have, as we just saw, a lot of users that are developing container infrastructure on top of OpenStack. And so they need tools to better manage container networking and integrate that into the underlying infrastructure. We have a service called Courier. We have things that people need to improve the security posture of containers. You look at the edge space, as we've already talked about. Deploying an edge environment is very different than deploying a data center cloud. So there are some things that we're working on, but we also see areas that we need to go. And I think that the key here is we need to give all of these users and the developers who are working on these space to collaborate in the open and to build around our core set of functionality, but really let them drive the direction of this to meet their needs.
So once you have the use cases, you've brought the communities together to collaborate, you've built the pieces that you need to glue it all together, then you have to test everything from end to end to make sure that that integration is real, to make sure that it's stable and reliable. And a good example of this kind of end-to-end testing, the OPNFV project has the XCI, which is their cross-community CI. So they're not just testing individual components, but like a full end-to-end stack for OPNFV. The Zool project that Monty talked about earlier is another important piece of this. So that is a major component of OpenStack's own CI. But as he mentioned, the new version, version 3, has really been ramped up to be usable by other communities. So it's in a perfect position to now help us doing cross-community integration testing. Another important piece here is a community effort to do large-scale end-to-end testing called OpenLab. And this is to improve the user experience and performance. And some of the initial targets of this are Go for Cloud, Kubernetes, and Terraform with OpenStack. This effort is a community effort spearheaded by Huawei, Intel, Open Telecom Cloud, and VexHost.
And so, that end-to-end testing is something that we have experimented with in OpenStack, but with the launch of OpenLab, it's something that we're going to start putting more front and center. And that's something we're kicking off this week. And the team that's been getting that off the ground would love collaboration. So if you are passionate about testing and making these technologies work together, please come join the OpenLab effort. So, these 4 steps are really critical if you want to take different technologies, whether you're talking about technologies within OpenStack or kind of the broader open infrastructure ecosystem, and you want to make them work really well together and deliver value. And so, thanks to Allison and our joint leadership team within the OpenStack community, we are really putting a focus on this over the next couple of years to drive integration and make a lot of activities that we do support these efforts so that we can solve those problems for users. So thank you, Allison, for joining us to talk about it and for the work this year on helping us to get here. Thank you. So those are some of the things, specifically that we are going to go out and work on. I think that one of the other pieces about this that's really important is to think, how do we organize those efforts and how do we organize the community overall? Because I think going back to that map, we have that core infrastructure services, that set of core infrastructure services that so many of these use cases depend on. But there are also differences when you're talking about an edge environment or a CI/CD environment. And I think we have an opportunity to start to think about ways to bring people who want to solve common problems together and really build that glue in a focused way for different kinds of use cases. And these are just some examples of some of the areas that we're starting to look at organizing these teams together around. So this is going to be a big topic for discussion this week. There are forum sessions that deal with a lot of these different use cases and problem domains. And on Wednesday at 4:30, we are going to have a forum session to talk about kind of the strategy and how we as a community want to organize and pursue this integration approach. So please join us there and help us make progress on this. So we've talked about where we started, some of the things that have happened along the way, and some of the things that we've learned this year that are really creating some pain points for users. And I think that when you see a pain point for a user like that, you can look at that in a few ways. But the way I like to look at it is as a huge opportunity to go make things better for them. And this is the right place to do it. This is the community to do it, because we do have those engaged users here. We have the companies that are here participating, contributing, and part of this community to help drive us forward. We have an incredibly active base of software developers that have already tackled an amazing number of problems and use cases. And we can continue to iterate on this and apply that active developer base to new problems. And we have serious use cases, like the ones that we talked about with China Railway and Commonwealth Bank and AT&T and others, that are giving us a real goal to shoot for to go out and address these issues. I think that overall, in the open source ecosystem, we are at an incredible point. And in OpenStack, we have one of the largest open communities that's ever existed. And so that means we do have great opportunities to go after these different challenges. It also means we have a big responsibility to tackle these problems head on. So I think that this is the right community to do it. We have a very important, critical mission to go after. So let's go make this the place where we're going to continue to build an integration engine that solves some of these biggest issues that are facing open source users today. So to keep the morning going, it's going to be a great set of speakers that we have coming. And the first one that we're going to be hearing from is President of Business Operations at AT&T, Saurabh Saxena. But first, we've got a video. Thank you.
Stay with me, Mr. Parker.
When a critical patient is far from the hospital must come to the patient.
Stay with me, Mr. Parker.
The AT&T network is helping first responders connect with medical teams in near real time.
Stay with me, Mr. Parker.
Saving time when it matters most.
Stay with me, Mrs. Parker.
That's the power of AND.
Thank you, Jonathan, and good morning, Sydney. You're probably wondering, what does this video have to do with OpenStack? Well, AT&T is building the first US broadband network dedicated to emergency responders called FirstNet. OpenStack is at the core of the AT&T Integrated Cloud, AIC, one of the foundational layers of FirstNet. FirstNet has to be always available and hyper-secure. That means available even while doing OpenStack upgrades and new feature introductions. Additionally, FirstNet requires a multi-cloud, geodiverse implementation by definition. AT&T has many mission-critical services like FirstNet that are built upon OpenStack cloud infrastructure. To ensure these mission-critical services continue to exceed customer expectations, AT&T envisions that, as a community, we must rapidly evolve to deliver a next-gen OpenStack that provides enterprise-grade maturity. Hence, I couldn't agree with Jonathan's messages more. Integrating across core projects within OpenStack from the onset for feature delivery and end-to-end testing further lowers the barriers of adoption. Doing so provides efficiencies, time savings, and much greater agility so enterprises can shift focus to delivering solutions and services on top of a strong and flexible cloud foundation. To demonstrate the need for another key theme in Jonathan's keynote, let me touch upon edge computing. Edge computing is going to be a critical enabler of next-generation applications like augmented reality, virtual reality, real-time robotic controls, and 5G applications. Decisions will need to be made much closer to the users. It also needs to be lightweight, and compute footprint has to be much smaller. More than OpenStack is required to support the end-to-end full stack. To do so, collaboration across multiple open source communities is a must. With that introduction, let me share the script for the rest of my talk. I will share some AT&T services enabled by OpenStack, give you an update on our AIC progress, walk you through a strategy that we are pioneering within the community to deliver a next-gen OpenStack. Then I will be joined on stage by Ryan Van Wyk, our Assistant Vice President for Cloud Delivery, and Ellen Meadows, our lead cloud architect, to demonstrate an example that supports this strategy. And finally, I will have a call to action for all of you to join in the strategic evolution, because we firmly believe it will advance OpenStack. So let's get started. AIC supports all businesses and consumers' communication needs with OpenStack at its core. These services demand a cloud platform with enterprise-grade maturity. This context is important given that a significant base of the large-scale OpenStack production deployments are implemented by communication service providers. For example, enterprise customers' dedicated internet services are delivered on demand via our virtualized customer edge routers. DirecTV Now is our over-the-top offering with nearly 500,000 subscribers. And Cricket Wireless, an AT&T subsidiary, provides about 2 million customers with wireless talk, text, and data capabilities. And there are many more. Given that OpenStack is at the foundation of these critical services, I would like to share our progress since the keynote I presented at the Austin Summit in 2016. In that keynote, I described our challenge to address the 114 petabytes of data traversing AT&T's network on an average day. Today, that number stands at 168 petabytes and is expected to grow 10x by 2020. As shared previously, the only way to meet this exponential demand is to virtualize 75% of our network by 2020. Today, we are well on our way towards that goal, thanks in large part to OpenStack and the community here. It is clear that realizing this software-defined network is no small task. Currently, there are over 100,000 cores of compute capacity deployed across 80+ production OpenStack regions located in 10 different countries. As we have demonstrated, scaling AIC requires collaboration with the OpenStack community, and the collaboration continues to grow much stronger with each release. Our innovation-driven phase 1 successes have been significant. Now on to the next gen of OpenStack, delivering operational maturity with ease. Today, large corporations are rapidly adopting OpenStack, so it is imperative that we work with a sense of urgency to deliver enterprise-grade maturity. To do so, we believe the next-gen OpenStack needs to satisfy a few critical demands. First, let's start with something that's been making headlines: massive security breaches. Just like you take your personal security seriously, enterprises always put the security of their customers' data first. OpenStack must embrace security by design. An example where we can improve as a community is making security scanning and vulnerability closure one of our highest priorities, and to do so for all projects. To help drive security by design, we are working within the community to enable role-based access control automated validation. Automation of these highly critical scenarios will allow enterprises to implement the best practice of least privilege access with confidence straight from the community code base versus compensating via internal development and controls. Second, enterprise scale demands that day-to-day operations be fully automated. The next-gen OpenStack changes the actor who's managing and operating the cloud. The next-gen cloud is operated and managed by software. One example would be implementing standardized health APIs across all projects to further enable software-based orchestration to self-heal operational issues. AT&T is leading several forums this week focused on this area. Finally, multi-region, large-scale enterprise production demands on OpenStack that supports hitless and seamless upgrades. AT&T is collaborating actively in this area to drive absolute predictability into platform delivery via containerization and orchestration. Without this maturity, the community at times is leaving up to the end user to address the challenge, ultimately inhibiting OpenStack's true potential. OpenStack is at an inflection point, and maturing it to solve these types of challenges goes beyond just technology. Our community must evolve our culture and processes. The first step in this evolution is to clearly define and communicate the core projects of OpenStack like Jonathan just did. This allows the technical committee to truly focus on driving enterprise-grade maturity at the core. For example, how do we determine if an OpenStack project is enterprise-ready? Enhancing project maturity metrics to ensure enterprise features, best practices, and operational needs are cared for will answer this question. Our community can embrace key learnings from mature and successful open source projects and integrate with them, again, just like Jonathan touched upon, to improve our approach to delivery. Another area, enhancing and formalizing backlog process to allocate release capacity consistently for operational needs. To give you a real-world example on this strategy in action that we've been working in collaboration with the community, I would like to invite Ryan van Wyk and Alan Meadows on the stage.
Thanks, Saurabh. Today we're going to demo our AIC container platform, which leverages a set of open source projects that we've been actively collaborating in the community on. We are going to show you guys how we can achieve deployment speed and predictability, as well as frequent upgrades to the platform with no impact to the running workload, which, as Saurabh mentioned, is a critical requirement of enterprise-grade maturity. Okay, so let's get into it. Our first scenario demonstrates how we can add a new compute host into an existing OpenStack environment with zero-touch automation. And for today's demo, we're going to show this part of it using an accelerated recording, given the time it takes to provision bare metal. What you're seeing on the screen behind me is our site design tool being used by our data center engineer to change the existing site design, and in this case, we're adding the new host into the environment. The tool is automatically determining the cable design, IP addresses, and other physical and logical configurations that are needed. These design changes are being translated into YAML that's being used to instruct the system on what to provision, and it's the same process that we use regardless of the configuration change. Alan?
Thanks, Ryan. So what happens next is we submit that YAML design to our containerized control plane, where it realizes that a host in the design is unprovisioned, and it kicks off bare metal provisioning for that host. At the tail end of that bare metal provisioning process, we automatically join that new host to the region's Kubernetes cluster. Additionally, we apply the appropriate labels to that host, whether we target it as a control plane host or a tenant compute host, so that it receives the right OpenStack workloads automatically. And finally, the really great thing about this approach is that there are no other automation technologies involved besides bare metal provisioning, containers, Kubernetes, and Helm. This simplicity is what enables us to achieve a predictable process every time and allows us to seamlessly perform this rack augment to an existing environment. So to sum it up, we've taken a brand new host with a single click. We've enabled that host to receive OpenStack VM workloads without disrupting our existing environment.
Okay, so now that we've demonstrated that we can change the physical environment predictably and with speed, let's move on to the live demo. Let me pull up our DirecTV Now video running in the same environment that we just completed the rack augment in. Alan, can you kick off the upgrade?
Yeah.
As Saurabh mentioned, DirecTV Now is a critical service that we have running on our OpenStack cloud today. And we're using it here to stream while we're doing the upgrade to show you that there's no impact to the running workload as we execute a zero-touch upgrade from Newton to Okada. Alan?
So first, a little contextual setup. You'll notice by examining the container list up on the screen that every OpenStack service in this region is containerized, including the infrastructure itself. We're essentially running a single command to kick off our upgrade using an AT&T open source tool called Armada. It'll orchestrate multiple OpenStack Helm charts. It's processing a declarative YAML file that defines our entire OpenStack Helm Okada installation. It's walking through the existing Helm releases and determining which of those need to be upgraded. And once that process is complete, we really hand over the heavy lifting to Kubernetes to perform the rolling updates on the appropriate OpenStack services.
So one of the objectives of our platform is speed. And this is a major upgrade that we're doing, and we've done it a couple times, as you can imagine, and it takes about 4 minutes. But how is that possible?
Well, because everything in this environment is containerized and we're performing the upgrade across all the OpenStack services in parallel, we can achieve this type of speed predictably.
So speed is great, but how are we able to achieve the upgrade without impacting the workload?
Well, the full explanation is probably a bit complex to get into, but we can sum it up simply with 2 essential ingredients. The first is that we're leveraging the built-in functionality in Kubernetes to perform rolling updates. But second, the process is taking advantage of our collaboration in the community to define and bake the required installation and update logic into OpenStack Helm charts for each OpenStack service.
So predictable deployments and upgrades are critical to realizing enterprise-grade maturity in OpenStack clouds. And Saurabh talked a little bit about that. So how is this Helm-based container platform helping us to solve for this?
Well, so you can see many containers up on the screen and in init status, and they're not yet running. Each of our Helm charts maintains its own awareness of the OpenStack and infrastructure services that they depend on. So whenever a container or a Kubernetes job spawns as part of a greenfield deployment or an update, it ensures that all the services that it needs to work with are up and available, and ensures a consistent startup and workflow order. An example of this would be the Keystone endpoint registration jobs that our OpenStack Helm charts perform, ensuring that the Keystone service itself is actually up and responding before we attempt to register or update endpoints.
So Alan, we're demonstrating an upgrade here today, which is one scenario, but if we were to change the demo, for example, and just need to do some configuration changes to one or more OpenStack services, how would that affect it?
Well, so whether we're doing an initial installation, feature releases, or just simple configuration changes, or even a major OpenStack upgrade like we're doing here today, this process uses the exact same workflow for all of them. This means that we only have one well-tested process to maintain and ensures that we can keep that process predictable.
So speed is not only about deployments, right? Us as a development team building out a large cloud need the ability to rapidly evolve our platform based on changing business demands. Can you talk a little bit about how moving to this containerized platform allows us to achieve this type of flexibility?
Yeah, sure. So the move to containers not only allows us to easily scale replica counts for horizontal scaling and resiliency purposes, it also allows us to be very targeted about the specific services that we ramp up in a region. But not only that, this platform allows us to approach entirely new ways of scaling, such as easily creating dedicated containerized infrastructure for every OpenStack service with only minor changes to our declarative YAML.
So another goal that we set for the team was to look at driving footprint reduction. It was mentioned here today, edge computing, right? And so how is moving to this platform helping us solve for that problem?
Well, by moving to containers, we've reduced the physical footprint required by our OpenStack control plane by an order of magnitude. Prior to the AIC containerized control plane, we were carving out large portions of resources for stacked VM-based OpenStack controllers, where now we have individual containers for each microservice, and they're consuming far fewer resources. So it looks like our upgrade is at the tail end of its process, so I am going to quickly refresh the OpenStack dashboard, and we should see the Okada logo.
OK, so to sum up, we just completed a major upgrade of OpenStack. We did it extremely fast, totally predictable, otherwise we wouldn't be doing it live in front of you guys today, and no impact to the running workload. Back to you, Saurabh.
Thank you, Ryan and Alan. Working with the community, there's some critical challenges that they've just demonstrated how we have solved. This shows that our OpenStack community can solve these challenges and much more. There are many opportunities to collaborate on a next-generation OpenStack at this summit, including a hands-on workshop with OpenStack Helm on Wednesday at 1:50 p.m. As I mentioned in my opening, mission-critical services like FirstNet are running on OpenStack. Millions are depending on OpenStack delivering always-on, hyper-secure, high-performing, geographically dispersed cloud that is also easy to manage and operationalize. Thus, it is imperative that the community's endeavor to deliver enterprise-grade maturity continues at a rapid pace. OpenStack is the foundation upon which our software-defined network stands because we believe this community continues to evolve and will meet any challenge. Software-defined networking is a critical OpenStack use case. In closing, being in Sydney, I think our community can learn from the wisdom of Joan Utzon, the incredibly brilliant architect of a highly complex structure, the Sydney Opera House. To Joan, details mattered. Flexibility and adaptability were critical. Hence, he built a modular and extensible architecture, developing into the framework ease of maintainability right from the start. That's why, while it was a painstaking effort to build the Sydney Opera House, it has stood the test of time and is a World Heritage Site. I think we can replicate that with OpenStack. Thank you for your time, and enjoy the summit.
Thank you, Saurabh, and to his team. It's a really great example of collaboration and integration across communities, and they really do a lot for OpenStack, so we appreciate it. And we also have quite a few other telecoms that are here speaking at the Sydney Summit. You can check out the telecom track on the agenda, but there's a couple of highlighted sessions on the screen as well. So today we released our user survey, which we've been doing every 6 months. And one of the most notable things that we saw looking year over year from 2016 to 2017 is the shift to mainstream industries outside of IT. And one of the industries that had the most significant growth was financial services. So today we're going to hear from Commonwealth Bank, which is one of the largest banks here in Australia. And next up, welcome Quentin Anderson to talk to us.
Thank you. Morning, everyone. I'm head of systems engineering for a part of the Commonwealth Bank called Analytics and Information. The Commonwealth Bank is one of the larger banks in Australia, one of the largest banks in the world by market cap. And the bank's vision is to excel at enhancing the financial well-being of people, communities, and businesses. This, for me, is a pretty awesome vision to get behind. Financial well-being is a vital part of the everyday lives of ourselves and our businesses, and really figuring out what it takes to enhance financial well-being is quite a complex thing. And when you think about all the different aspects involved in doing that, there's quite a few, but the two key areas that I focus on or that I concern myself with are data and experimentation. When you think about what it takes to not only personalize, but fully target and really understand what your customers need, it's very much a data and experimentation exercise. We started down this journey circa 4 to 5 years ago, really trying to mature the way that we approach both management of data and machine learning for that purpose. And if you think about what is the maturity steps that you might go through in order to really have a data-driven and an experimentation-driven organization, you start with the basic process of experimentation, kind of a first level of maturity. You get some data in the correct place, and you start to generate some experiments. And the experimentation process is interesting. You learn a lot, but it's not fundamentally the place you need to get to, because experiments are often brittle, very much a scientific process. And so you've got to get to a next level of maturity, which is, how do I take those experiments and how do I go from the lab to the factory? How do I get to the state where my experiments result in predictions, result in customizations of the way I engage with my customer and the way my product systems behave in a way that is reliable, operational, productionized. And so that's kind of the second level of maturity. And you spend a lot of time figuring out how you're going to deal with your labels, how you're going to monitor your data, how you're going to monitor your models. The third level of maturity you get to is, well, now you've got some experiments which result in predictions which are reliable, but you've fundamentally got to impact the customer experience and the way the business operates as a result. And we call this third level of maturity decisioning. And so the representation that you see here is logically what our resulting data environment looks like. So we have kind of two major use cases. The one is this third level of maturity around experimentation and prediction, which we call decisioning. And that's all about closed loop interactions, integrating analytical processes and data management processes into the product systems to impact all kinds of different decisions, what the customer sees when, how we engage with the customer, et cetera. And then on the right-hand side, information for people, which is allowing our internal staff to know what's going on, not only with our business, but with our customers' business and within our customers' lives, and make good decisions in business operations. From a technology point of view, the way we do this is we have some fairly large Hadoop clusters. We also have some fairly traditional data warehousing technology. And the Hadoop clusters, when we started off down this journey, were entirely based on physical servers in our data centers, running RHEL and just installing Cloudera directly onto those servers. And that worked in the beginning, but as you can imagine, comes with a bunch of inherent constraints which we needed to work through. The primary ones, obviously, unit cost, cost of change every time we have to do large upgrades, et cetera, but also the developer experience was not amazing. And so we departed on a journey to try and cloud enable some of these technologies so that the process of experimentation was a lot faster for our business, but also a lot cheaper and a lot more deterministic. So the technology stack that we landed on is not all that unique. It's fairly typical. We've got OpenStack at the bottom, and we run Ironic for that. The reason for Ironic for the initial set of use cases is the big data processing, very much stateful services want to be close to disk. And also, increasingly, as we move into microservices, the VM abstraction is in a lot of ways uncomfortable if you want to drive immutability. On top of that, we run Ubuntu. We use Docker for containers, Calico for container networking, We use Vault for secrets management, and then moving up, we use Mesos and Marathon for resource orchestration and effectively a PaaS API. And on top of that, we run our big data applications and finally end applications on top of that. So this is a fairly typical stack. It's container cluster. It's container cluster on top of a cloud. What we feel like we've done fairly uniquely is we focused on continuous delivery at all layers of the stack. We also focused on versioning through codification and immutability at all layers of the stack. So for us, an upgrade of an operating system or even changing the permissions on a folder inside an operating system in an underlying host is not a matter of SSHing into a box, but rather updating a declarative form of the environment and issuing a pull request and allowing the tooling to make all the changes on your behalf. This is true for operating system, it's true for container, it's true for container clusters, container orchestrators, monitoring, alerting, absolutely everything. We use the same basic interaction pattern, which is versioning through codification, automation through codification, and continuous delivery, applying the changes off the back of that. To go into a bit more detail around how that workflow looks, we separate out a module repository, which has the source code, the tests, the pipeline, the build, etc., for a particular module. A module might be a container within the control tier. It might be an app. It might be anything that's going to be executing inside an environment. And we separate those module repos from our environment repos. And the environment repos contain declarative forms of the environment. It's a fairly common pattern to have declarative YAML or JSON files to define what the environment needs to look like as opposed to what changes you need to apply to the environment. And we try and ensure that these things are strongly versioned. So I have a declarative form of my environment sitting on master, and this represents what's running inside production or inside the designated environment. I fork the repo from that point. I'll make some changes, either upgrading, introducing hosts, deploying new clusters, deploying new applications, and I issue a pull request against the deploy branch. The build tooling will then generate a change plan and attach that to the pull request for me. You can think about this workflow as being pretty similar to HashiCorp's Terraform, where it's going to generate a change plan, but we've integrated this very strongly into GitHub and therefore into version control. So the tooling will go off, generate a change plan for you, attach it to the pull request, describing if you were to merge this pull request, these are the changes that I'd apply to the environment for you. We then have a number of bots, for want of a better word, that will go and do reviews of those changes. Is there enough capacity in the environment? Are you introducing a risky change? Are you deploying into the correct environment? Are you a junior developer and therefore you shouldn't be pulling against production, so forth? And so there's a bunch of automated checks that take place at that point. There's also a bunch of manual checks because it's a pull request. Humans go and take a look at the proposed changes. When the pull request merges, the tooling goes off and applies the changes into the environment. And so you can think about what's sitting on the deploy branch as being effectively the desired state, what's sitting on master as being the actual state or the previous state. And the tooling is going to go off and apply those changes to the environment by making API calls to Nova or to Marathon, HashiCorp Vault, so forth. And once the changes have completed, it will then merge the new declarative form back onto master. And so you've got desired state, you've got actual state, you've got an interim desired state convergence, which are in your logs. And when you get failures in the deployment, it's fairly easy to debug from that point. Of course, as you do smaller and smaller changes, that problem becomes less and less. So when you think about this, what we land up with is various types of composition that are going on. And what we've done in this overall stack is that we've composed a rather large number of open source projects together in order to generate our business outcomes. And when you think about the type of composition that you're doing, there's build time composition. I'm bringing two libraries together and I'm putting them into a Docker container or into a jar into a Docker container. I'm doing deploy time composition, something like sidecarts. And I'm also doing runtime composition. I've got microservices and APIs, and they're interacting with each other. And we believe strongly that versioning through codification gives us an absolute base case to be able to change all of those different levels of compositions and therefore services and systems in a sustainable manner over time, because it allows us to recreate environments, it allows us to build automation in a scalable manner, and it allows us to recreate environments and therefore have automated testing, which is the basis on which safe change can take place. So with that in place, or with those basics in place, there's a fair number of open source projects that we've worked towards, that we've integrated in order to achieve some of the outcomes we have. So we started with OpenStack as being the basis for this approach, and in order for you to even just do immutable and codified access of your infrastructure, OpenStack, ironic, is the first place you start, and then it's a build-up from there. Over time, we're moving the same approach over into our public cloud environments, because we very much have a hybrid cloud strategy. If you take then from the top down, software supply chain management, Jenkins, Notary from a trust point of view, and various tools, OpenStack being an example, but lots of others in the supply chain management side of things, which are all part of pipelines, but enforced through the codification approach I described. In the analytics space then, R is a major tool of use from our data scientists, and Hadoop, increasingly Spark as a part of the Hadoop ecosystem. We still have a fair amount of HDFS from a stateful workload perspective, and increasingly Cassandra. And starting small, but an increasing amount of TensorFlow coming in. Going down the next level, I've mentioned Vault a few times. We use Mesos primarily in the stateful space at the moment, and increasingly in the stateless space, Kubernetes. Calico gives us the container networking. Calico's got some nice aspects in that it's simple, but also it integrates really nicely with existing networking environments across the different cloud providers. And we use Docker as our containers, and Ubuntu as the hosts across the different cloud providers. This provides us not only a nice environment for our stateful and our analytics workloads, it also increasingly is providing us with a nice environment to host different types of workloads, pure microservices. It started with just data science dashboards, Python user interfaces, Python dashboards, R Shiny, etc., and increasingly is going into our more web-facing workloads and microservices. It's been a really interesting journey to start with composing OpenStack in some basic container environments and work through the entire process of composing the rest of these open source technologies using a strong approach of getting the basics right first. Thank you very much for your time.
All right, thank you, Quentin. We appreciate it. I mentioned earlier that financial services is one of the fastest growing industries that we have, and I wanted to highlight another group that is kicking off this week, which is the financial services team. China UnionPay is actually one of the founding members and helped get this started, along with help from Intel and SUSE. So if you have an interest in financial services, please join that group kicking off this week. And we're also going to hear from China UnionPay about their story, as well as Insurance Australia Group. So some great sessions coming. So next up, I would like to introduce Annie Lai. She is a board member at the OpenStack Foundation. She's also a board member at CNCF. She's everywhere and an inspiration for us. She's been very instrumental in building the OpenStack community in China. And this is a picture from OpenStack Day China that happened earlier this year. And she also has helped bring in a lot of new members. So next up, Annie Lai.
So for those of you who are not familiar with the China market, I think the easiest way to explain who Tencent is to use the following analogy. We all know that in US, there are 3 internet giants, Google, Facebook, and Amazon. In China, we also have 3 internet giants. We call them BAT. I'm not talking about the bats who work at night only. I'm talking about BAT. Baidu, Alibaba, and Tencent. Tencent is considered one of the 5 largest internet and mobile gaming companies in the world. Tencent is known for its WeChat, which is their mobile social platform mostly. WeChat serves over 953 million monthly active users. It allows its users to do just about anything, from playing games, giving people money, making video calls, sharing moments, ordering food, taxis, reading news, etc. For businesses and organizations, WeChat is also a very powerful marketing tool. Now, I would like to invite today's Tencent speaker, Mr. Liu Baoyuan, who has been actively involved in OpenStack-related projects since 2012. Now he is the chief architect of Tencent's T-Stack. Baoyuan.
Hello.
Here. Where is it?
Okay.
Okay. So Baoyuan is using his phone, and this is a real-life demo. I hope he's not getting like private messages in the middle of the demo. Okay. So we're starting this OpenStack promotion using WeChat. Isn't that amazing? Let's give a round of applause to Tencent and Baoyuan. So for next few minutes, Baoyuan is going to share with us how Tencent use OpenStack for their internal IT applications, research and development, as well as serving their enterprise and government customers. Without further ado, Baoyuan, take it away.
Okay, thanks, Ellie. Good morning, everyone. I'm Baoya Liu from Tencent. And in this section, I'd like to share some stories about our successful journey of OpenStack. At first, I'd like to say something about our company, Tencent. Our company was founded in 1998, and it now has 37,000 employees all over the world. The first product of our company is QQ, but most of the foreigners know about Tencent is from the WeChat. Both these two products are the key products of our company, and both of them has about 1 billion active users per month. And also, Tencent is the biggest game company in the world. As we are running a large internet-based service, it is very important to build a strong IT system to support these businesses. And in 2011, we have launched an open platform strategy. And this strategy aims to open those excellent IT platforms internal Tencent to open to the society to provide service. And also, this is the former part of Tencent Cloud. After 2 years of operation and running, the Tencent Cloud is officially opened to the society in 2030. And with the rapid development of Internet, the Internet service brings an unbelievable change to the whole society and makes our life feel better. By the end of 2015, our CEO, Pauline Ma, proposed the Internet Plus strategy. And this strategy aims to use Internet service to use Internet service to collect all the people, all the services in the society. And this strategy was written into our national report by our Prime Minister. To achieve this strategy, all the Internet services are running on our cloud, mostly the private cloud. And this picture shows the original changes about our IT systems. Before we move into the cloud, we have almost 6,000 servers and 80,000 desktop terminals. And all these resources are dispersed into about 6 data centers. And we also have more than 70 workplaces in the world. In order to centralize these resources and provide better resource services, we have built the Tencent OpenStack platform named T-Stack. Now, we are using OpenStack to build our private cloud internal, and we have about more than 30,000 cores under the management of OpenStack. And we use OpenStack to provide services for our IT systems, such as the email system, the internal communication systems. And we also use OpenStack to provide the environment for our CI and CD. And we use OpenStack to the analytic module to manage the environmental server. For those people developing with the AI, we use OpenStack to provide the GPU service for them. With the operation and running the T-Stack internal IT systems, we have reduced the server cost about 30%, and reduced the operation and management cost about 55%. We do not just use OpenStack to support the internal systems. We also use them to support our other business systems, such as the video, the music, and the games. And very typical use case internal the Tencent is the WeChat. Now, the WeChat has nearly about 1 billion active users per month, and more people are using WeChat to buy things from merchants. And the procurement system of the WeChat are running on the T-Stack and provide service with our OpenStack platform. Now the systems are supporting about 50 million merchants, and there are 200,000 orders per day. Nowadays, more and more people are choosing private cloud to build their IT systems, especially for government and the large enterprise. But they also have the requirements of public cloud. They usually want to put their internet-based services directly into the public cloud. But Tencent has both public cloud and private cloud. Tencent can build a hybrid cloud within several hours for the customers. In order to activate the Internet Plus strategy, we are bringing the T-Stack from the internal IT to the society. We have helped some governments and some enterprise to build their private cloud, such as the Guangdong province and the Sichuan province. And this is the use case of Xiamen Government Cloud. Just in September, we have helped the Xiamen government to build a private cloud to support the BRICS Summit. And there are 5 important businesses are running during the summit. And the security service in OpenStack is a little weak, but Tencent has imported some security company and also import our security service on the public cloud to achieve this goal. The traditional security service can support the bandwidth of anti-DDoS is about 100 GB, but with the service of public cloud, we can serve about 600 GB of bandwidth with our security service. Except for the government example, we also help some large companies to build their cloud too, such as the Tencent Steel Industrial Cloud. And this cloud is built for Tencent Steel Group. This cloud is not only used for their own, they also use this service to provide to all the industrial in Hebei province. And not only they consider the ICE platform, they also considering to use our big data platform to help them to analyze their data collected from the product line in order to increase their production. Their final goal is to achieve the intelligence of manufacturing. Thanks for listening. Okay, that's all.
Wow, that is incredible. You know, I love data, and that's one of the reasons I love China, because you can round to the nearest billion, and you know, it's no big deal. I believe he said they have almost 1 billion users on WeChat, and you know, we heard about China Railway earlier, and they have, I think, 100,000 kilometers of track and 2 billion plus passengers riding every day, probably on WeChat the whole time. And so China is an amazing place for OpenStack, and we're happy we can be part of it. One other thing I love is our super user publication. This is a place you can learn about all these amazing user stories in between summits. And I'm extremely proud to be able to introduce to you the two people who lead super user, and that is, of course, Allison Price and Nicole Martinelli.
3 years ago, we launched Super User, an online publication where we share case studies, tutorials, and thought leadership pieces around all things open infrastructure. We couldn't do it without contributions from people like you in the community.
Because all OpenStack users are super users, teams of any size can apply. The community rates the nominees, and then our editorial advisory board picks a winner.
3 years ago, we started the Super User Awards at the Paris Summit. Since then, we have recognized 7 organizations who are not only innovating with OpenStack, providing real business impact to their organization, but also contributing right back to the community. Most recently in May, at the Boston Summit, we had our first tie. UK Cloud and Paddy Power Betfair won the Super User Award. So today, to pass the torch on to the Sydney Summit Super User Award winner, we have Thomas Andrew from Paddy Power Betfair.
Right, let's announce the first finalist. With over 31 billion daily average page views, 24/7 uninterrupted operation of real-time dispatching management for all the trains, locomotives, and vehicles, China Railway Corporation. With 500 million users and 50 million transactions per day, 3,000 transactions per second at peak, with 100 billion yuan per day, China Union Pay. With 8 regions across 3 continents, they have shifted to 100% focus on OpenStack, which has been key to the global expansion of their organization, City Network. With OpenStack, they cut server costs by 30% and operations and maintenance costs by 55%, saving more than 100 million yuan each year. The Tencent T-Stack team. The winner is the Tencent T-Stack team.
Shut up. They don't know this. Congratulations.
Congratulations.
We're going up.
Congratulations.
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 All right. Thank you very much. Congratulations. And thank you again to Allison and Nicole. Amazing. I told you China, there's big things going on there. It's incredible. You know, I think that we have seen some really cool use cases about cost savings, and including the one we just heard about from Tencent. And back in Boston, we actually heard from the U.S. Army Cyber School, saving millions of dollars for U.S. taxpayers. I happen to be one, so I'm happy about that. And, you know, of course, our Super User Award winner just talked about saving 30% on their server costs. So to tell us another story about another industry using OpenStack, I'm really excited to welcome from the Adobe Advertising Cloud, Joseph Sandoval and Nicola Bru.
Massive amount of data, the explosion of devices and screens, skyrocketing customer expectation are all forcing business to rethink their approach. It's not anymore about the product only, the supply chain, the online or the offline. It's so much more than that. It's about the end-to-end customer experience. One way we are helping our clients in their experience business journey is with the Adobe Advertising Cloud. It's the first end-to-end platform for managing advertising across traditional TV and digital formats. Sorry. It's a lot of people. That's very impressive. Thank you. All right. So this platform makes it simple to deliver video, display, search advertising across any screen in any format. This independent cross-channel platform allow you to identify and engage the best audiences with a consistent and relevant ad experience. Let me give you an example. When you go to your favorite website to watch a video, before your video starts, you will have a bid request sent to multiple providers. All these providers are going to compete together to win and show you an ad. For each auction, we have to make a real-time decisioning to choose the best ad to show you, given the user information we have, given the context we have, and also considering that we need to optimize for the bid price for an efficient return. So at the technical level, it's really like managing a stock exchange for advertising.
Yeah, so as Nico mentioned, our platform is very highly transactional. And so it presents a certain set of challenges. But I want to give you a little bit of backstory because our story is kind of like slightly different. We were a startup that was born in public cloud. And the great thing about public cloud is it's a great area where you can really get started. You can kind of really enable yourself to really prove out your business model. And then as you continually grow, you don't have that investment of getting into a data center and all the CapEx and complexity that's involved with that. And so for us, as we were starting to scale, certain challenges starting to really present ourselves in the public cloud. One of these things is that our customers have a certain expectation where we need to be able to deliver a packet under 50 milliseconds at the 95th percentile, as well as we started to grow, the scale started just going off the charts to the point where now we're at 200 billion requests per day. And so on the Amazon platform, the great thing about it was, it's very mature. There's a plethora of options. You're going to find instances that are compute optimized. You're going to find instances that are memory optimized. But for our use case, which was very network intensive, it started to become a challenge in regards to, could we scale on this platform without it eating into our business profits? One other area that we had challenges as well is that we have huge data sets, large amounts of data that we really need to move billions of objects from A to B. And at a certain point, when you just start to scale, you almost get into this Hotel California situation where you got so much data that it's going to be very difficult for you to be able to move out. And so these really were times where we started considering that maybe it was a time that we needed to consider to pivot and to move back into private cloud. But that kind of raises some questions because we made certain assumptions. Would we be able to really realize cost savings if we move from public cloud to private cloud? Would we be able to scale our business without really scaling our team? Because one thing that's great about the public cloud is that you're able to kind of really scale without owning a lot of the infrastructure. And one thing I did appreciate, a recent tweet where someone made a comment about how there's going to be like two types of operators. There's ones that are learning how to run in a cloud-native way, and then there's others that just run in the cloud without the efficiencies. And then the third thing would be, could we run OpenStack in the data center in an efficient manner?
That's right, Joseph. So when we started this project in 2012, the cost efficiency was a key driver. So it's not just about the technical challenge we were facing, but at the time where everybody was moving to public cloud, coming to your executive to say, we want to move in data center is kind of a difficult discussion to have. And so we went through multiple TCO analysis, total cost of ownership analysis. We had to challenge our vendor and partners to understand what can we do, what are the risks, and how we can manage that. One great things we have been able to confirm is when we went live with our first deployment in 2015, was a clear A/B comparison of the cost between our public cloud deployment and our private cloud deployment. We saw a clear 30% cost saving, and this was considering the cost of people working on this OpenStack deployment, the cost of R&D, and the cost of infrastructure. That says, it's not just about the infrastructure cost. You need much more to be able to reach to the saving. You need to also have a clear, efficient approach on a lean infrastructure. Oops.
So, one meta that we really kind of came to, and if you ever work with me, you're going to constantly hear these things because I come from a very startup background, is where I really try to focus my teams. And, we have this ethos at the TubeMogul, which was acquired by Adobe, where we want to do a lot with the little, because definitely things are very lean. And so I would preach to the team that we need a lean infrastructure. So focusing on the APIs and services that are going to help our business scale. When we moved into the data center, we weren't trying to compete with public cloud. And so helping my team really focus on that MVP so that we could keep proving out this business model was going to help us to grow, as well as leveraging partners who could help us to be able to scale, like our rack and roll approach, where we can easily, because we built really modular, composable kind of designs, that we could easily expand compute, as well as really having a full tool chain where everything's in CI, and we could have confidence in what we were building so that even if we had to move quick and patch something, we knew that we could roll something out without really blowing up our business. But it wasn't without its challenges.
Right. So, like Joseph mentioned, a big part of the effort has been from A to Z, starting from the procurement to the deployment. Having a close relationship with our business stakeholder was critical for us to be successful. Like any engineering project, a big project, there is time where you have big success and some other time you have failures. And to overcome those failures, to overcome those roadblock or challenge, especially when dealing with bleeding edge technology, you need to be able to educate your partners. You need to be able to work hand-to-hand with your business stakeholder. That was something critical for us, working hand-in-hand with our business partner to understand the use case, make sure the team understand what needs to be delivered so we can prove the value of this approach. It's not about doing the perfect stack, the ideal public cloud solution. That was not what we are trying to build. We were really trying to solve a clear business problem. And this was possible with perseverance, with focus, and strong partnership. Leveraging this partnership, we have been able to deploy this year a cloud bursting approach very easily and quickly. This is only possible if you have this relationship with your partner.
So because of this, taking this really lean approach to scale our site, we started with 1 data center. We're in 6 data centers across 3 continents. We are right in the midst of just completing out, expanding to 100,000 cores, and we're pushing about 80 gigabits of traffic. And because of the community, we're able to scale. I want to thank the OpenStack developers for really having operator empathy, because as we moved we initially started at Icehouse to Mitaka, we've seen performance increase. We're able to maintain our infrastructure, and it's really because of the community that we're able to do this.
Sorry to interrupt, guys. Just anytime a new 100,000 core cloud is born, I show up with stickers. It's in the job description. But welcome to the 100K Core Club. So amazing. So I know you couldn't fly your whole team here, so I got you a stack to bring back. And
all right.
So that's for your whole team. Now, speaking of the team at Adobe, we all know it takes a pretty big team to operate OpenStack, especially at scale. And so there was no way you could possibly fly that huge team here, but you got a big stack of stickers. So let's actually show the team and recognize them here on the screen. Wow. So I'm confused. That only looks like 4 people. How in the heck are you running OpenStack with 4 people?
Well, like I mentioned, Mark, I think part of it is just as we've been on this journey with OpenStack, the community has really stepped up, and the platform has gotten easier to maintain. We're able to really do upgrades a lot easier. So for us, that's really helped us, as well as other strategic partners who have really helped us and helped us to grow.
Wow. Well, that's really impressive, but I'm afraid I'm going to have to get some of those stickers back. That's kind of awkward. OK, so you've talked about your philosophy as a manager and leading your team. And I believe that you were going to give us one more example of something y'all did recently with this fast-moving, awesome team.
Right. I think the best example we got this year is really this cloud bursting approach, where leveraging the infrastructure, the technology we put in place, and keeping a simple stack and understanding the business need very closely, we have been able to work with our stakeholders to handle a big peak of growth earlier this year. And in a couple of days, we have been able to put a POC in place to validate cloud bursting solution. And in a few weeks, we are production ready and able to leverage cloud bursting between our OpenStack deployment and our public cloud infrastructure.
Wow, so people have been dreaming of cloud bursting for a while. You actually have realized that you had a business need. It grew a lot faster than you expected. In a few days, you had a POC. In a few weeks, you had it in production. So congratulations, you've actually hit the holy grail of hybrid cloud, and you're doing it in production. So congratulations, and thank you again for sharing your story.
Thank you, everyone.
Thanks, guys.
Thank you, Omar.
You did an awesome job, by the way. Awesome. So next up, we have a speaker that I am always really excited that whenever we can talk him into coming out here and sharing his wisdom. He's been doing distributed computing before us marketing people showed up and called it cloud. And I've been called a fanboy of this particular person. And I do actually have a tattoo of his face, which it makes it hard for me to defend. But I will be exclusively revealing that tattoo on Twitter later, so you might want to check that out. And of course, I'm referring to the Vice President and CTO of Cloud Computing from Cisco, the one, the only Lou Tucker.
Welcome, everyone. It's actually such an honor to be here with the OpenStack community. And I often want to use these events as a time to sort of look where we've been and try to project where we're going to be as we go into the future. And I'm envisioning that as being this true world of multi-cloud computing. As we know, the internet continues to disrupt entire industries through these successive waves of innovation, whether it be in hospitality or in transportation, delivery of media services, and in cloud computing itself. And the impact in cloud computing has then also changed the way we think about machines. Nowadays, it's not unusual. We've seen 100,000 cores. We see warehouses filled with commodity rack-mountable servers. And this wasn't always the case. In fact, if you look back over the history of computer science, when we had vertically integrated machines going after speed, whereas what we know now is that scale trumps everything else. And in fact, these other machines now, you can see them in the Computer Museum. And there's a picture of one of them here I'd really like to call out here, a shout out to a connection machine, which I helped design, which is now going into the Museum of Modern Art in New York City next week. So cloud computing is clearly one. And almost every company now is having to adapt. 85% of the corporations are saying they're evaluating or using cloud computing. And those that are, 94% find that they're using multiple clouds. And so this means that Cisco itself has expanded our cloud portfolio as we continue to grow in the kinds of services and offers that we have for our customers, from our hybrid cloud solutions to applications that are delivered through the cloud, such as Meraki and collaboration services, towards security delivered through the cloud and making it possible for corporations to trust moving their businesses into the cloud, and as well as our traditional line of networking systems and cloud professional services. So one of the things that I think that we're realizing, though, most recently, however, is that there are still a number of challenges facing customers, particularly as they're now trying to understand how do they use their existing data center, their so-called private cloud, with a public cloud. And in fact, whereas we originally thought cloud computing was going to make everything so much easier, in fact, this is making it more complex. Because now your data might be spread over multiple systems. How do you handle authentication? How do you handle identity management? And how do you have the controls around so that you can trust that the services you're connecting to are those that you should be connecting to or your users should be connecting to? So this has been a real challenge that we see as we move into this multi-cloud world. So the customers are now asking, okay, so how do I evolve? How do I change my infrastructure to take advantage of these capabilities? How do I manage this kind of a hybrid cloud environment? And even more importantly, how do I develop new applications and services going forward? These are all the kinds of things that we at Cisco have been looking at, and we really have arrived at a kind of a strategy around multi-cloud, meaning that we expect customers to naturally use multiple clouds in addition to their own private data centers. It's not an either or, it's an and. And so what we want to be able to do is make it easier for customers to consume applications wherever they might be. So recently, we announced a partnership with Google in terms of making it possible for customers to take advantage of best of both worlds and combining the respective strengths of our two companies to make this possible. When we look at it again, what we are finding out is that customers wanted to be able to develop in the cloud or develop in their private data center and then deploy anywhere. They needed to be able to break down the barriers between private cloud and public cloud so they can access information on both sides or in any place in the world. At the same time, they still need to be able to enforce their network and security policies and be able to do that without losing a lot of the agility that they get by going to the cloud in the first place. And lastly, what you'd like to be able to do is there are so many new services around big data, artificial intelligence, machine learning that are taking place in the public cloud providers today. You'd like to be able to incorporate those into your applications. So all of these things are what Google and Cisco now are decided to work together on to bring these out in solutions. So of course, we all know there's been tremendous advantages and advances in the last several years with Kubernetes and microservices architectures. And this is largely because when we break a big monolithic app into smaller components, you can have those components developed by specialized teams. They can work independently. And each one of those services now can be designed to do something very simple and do it very well and be very and highly scalable. All of these things now allow you to then leverage a lot of the new services that we're seeing coming out in the public cloud, as I had mentioned before. However, those of you who have worked in distributed systems, such as I have for many, many years, know that they are hard, and that complexity and issues arise when you have to have multiple services working together to deliver a solution. I'm not going to go into a lecture on the CAP theorem and other things associated with that. But as you know, when you have lots of services that are dependent upon each other now, complexity increases. And this becomes even harder when applications span multiple cloud platforms. It's not just in your own data center or in your branch offices and your data center. Now you have public cloud providers and maybe multiple public cloud providers involved. This makes it much, much harder, whereas cloud computing was supposed to be very, very simple. So let's take an example of this. Here is a service that is made up of 4 services, each one specializing in a single component of this. We can use Kubernetes and pods to manage the life cycle of these components. And now what we have to do, though, is each service now has to handle communications around it. So we have to be able to do authentication. We have to be able to do traffic management. We want to be able to do load balancing across multiple pods. All of this has to be done now by each service. When you have multiple services, now you've got multiple teams who are each having to solve these problems and to try to do this in a consistent way so that they can work together. What if we change that model and we said, let's take all of those hard services around communications and put them into another service itself, aka a service mesh. The service mesh, we offload all those hard parts of each of those components into another service, in this case called Istio, where it does traffic management, where it can do authentication, where it can do secrets exchange, where it can interface into the security systems, where you can provide metrics for what's going on, and you get a total view of the communication between these services. This is this wonderful complement to what we're doing with Kubernetes, in that we're taking the hard parts about communication and putting that into a service mesh. In fact, this is something I'm really excited about with the partnership, because Cisco is now joining in Istio another open source project around this kind of service mesh for microservices. We're joining with Google, IBM, and Lyft, and bringing this capability forward into the world, where it can do load balancing, traffic splitting, A/B deployments. You have observability. You can do health checks. And all this makes those services now much, much easier to develop. The specialized teams can worry about how do they develop that feature and have all the hard part pushed off into the service mesh. To just quickly illustrate this, I'll take an example. We've got 2 services here, Service A and Service B. So think of Service A maybe being the front end, Service B being a sort of a back-end service providing content or access to information around the users or so forth. Each service, of course, consists of multiple pods. And we all know that Kubernetes can do load balancing across those pods, and we can do independent management of the life cycle. So one of the things we want to do now is that we want to bring up a new version of that service. So we spin up a new pod containing that service. With one line change in a YAML file, we can direct Istio to shift 5% of the traffic to that new service, aka canary deployment. Istio itself will now direct 95% of the traffic to the other pods. This way, you allow the developer to test out that new service, and if there's a problem, flip that back. If it looks like it's great, shift now 100% of traffic to the new version 2 of that service going forward. And this required only a single change in policy. None of the other services associated with this had to change. So we've encapsulated and abstracted the messaging and communication required into that service mesh, and the advantage should be obvious. So in this way now, for IT organizations who are trying to look at how do they span their data center, public cloud, multiple clouds, we can provide a consistent, policy-driven environment across the clouds themselves. And in fact, when we look at it spanning multiple clouds, now you can get access to all of the services. So from an application that you develop in a public cloud, you can access on-premise data center services. From the data center itself, you can now securely access the advanced services you might have in a public cloud. So in summary, then, I think that the long-term impact of this is going to be changing the way we think about applications and services development. With Kubernetes, Istio, and OpenStack, we can easily talk about managing applications as they are spread across multiple clouds. The boundaries, in fact, between applications and services become blurred. When that happens, application development becomes much more about an assembly process of ready-made, highly scalable, highly crafted, highly intelligent services. And that will allow us to enter sort of this everything as a service, multi-cloud world. Thank you very much.
Thank you. Thank you, Lou. So I am very excited to announce the next set of speakers. We're going to wrap up the day on a pretty fun note, maybe get our head above the infrastructure and learn a little bit about the discoveries that are happening on top of OpenStack. Many of you probably know that OpenStack has a very rich history in research, of course, starting out with NASA, and you've probably heard that CERN is running at a very large scale. But a year ago, when we were in Barcelona, we heard from Dr. Rosie Bolton about the square kilometer array and what they're doing to build that out using OpenStack. And 6 months ago in Boston, we heard from Dr. Daniela Roos, who's one of the leading roboticists at MIT, about the research that she's doing powered by OpenStack. So today we're going to hear about a local story, the Nectar Research Cloud, which is powered by OpenStack, and it's actually run collaboratively by several different organizations. So I'm going to bring out two of the folks who are helping to run that cloud, which is Dr. Stephen Manos from the University of Melbourne and Dr. Steve Connett from Monash University.
Thanks, Lauren. Thank you, Lauren. Hi, everyone. Hi, everyone. We're here to celebrate 6 years of sustained successful delivery by the Nectar program. It started way back in 2011, where as a national community, we got together and asked the question, what is the right infrastructure that will enable researchers to work together? The ambition was to support the connected researcher, where they would be connected to other researchers, to communities, to industry, to advanced analysis, and to vast amounts of data. And yes, you can guess it, the answer was OpenStack.
So since then, OpenStack has underpinned research outcomes of hundreds of research groups across Australia and also supported the collaborative endeavours of thousands of researchers across Australia and beyond. And as a national community of OpenStack operators spread across many cities and states, we have also contributed to the growth of OpenStack internationally. For example, we were an early adopter of cells since the Essex release years ago now, where Nectar-funded stackers worked closely with Rackspace and others in early deployments. This was critical to achieving a single cloud that operated across 7 organisations and 5 states in Australia. And as of a few months ago, we've had New Zealand join us as an international cell of the Nectar Research Cloud. We've also learned a lot about distributed deployment, lessons of which have been proliferated through OpenStack user committee forums, such as the large deployments team.
The same paradigm of global open source innovation has occurred higher up the stack. Researchers create their own bespoke environments. We call these virtual laboratories. And to aid that cause, Nectar-funded stackers participate in the Scientific Special Interest Group. They focus on the virtualization of specialized hardware, such as GPUs and interconnects. At times, what this means is at times, the researcher programs the computer that they actually need. They design it.
And what Stephen has described is really the essence of open source infrastructure. We believe that open computing, open platforms, open communities, and open APIs are a critical foundation of research. APIs will become and will be the universal language of discovery. Now, on to our 2 great science talks. These two talks you're about to hear do exemplify the goals of collaboration and the integrative nature of OpenStack. And they also demo some pretty cool research which is going to impact everybody in this room. First up, I'd like to welcome to the stage our Professor Brendan Mackey. He's the Director of the Centre for Climate Change at Griffith University, and I'd like to welcome Brendan to the stage. Thanks, everyone. Thank you.
Thanks, Steve. Thanks. Clicker. Well, good morning. It's a pleasure to be here. I've been asked to talk to you about our biodiversity and climate change virtual laboratory, which is really helping researchers to address one of the big challenges we have today, our biodiversity, all the species that live on Earth, the plants and the animals, the wildlife, also the things that want to bite you and kill you, like vector-borne diseases and viruses, and how they're being affected or may be affected by human-forced climate change. And all of this requires a lot of data and compute, analytical capacity. And by a lot of data, I mean a lot of scientific data. These are deeply curated data sets that conventionally have been very much siloed, that need to be brought together. The first are the biological observations that dedicated field researchers gather when they go on remote field trips to places like the Amazon or the Congo. The second are the data we have about environmental conditions. A lot of this comes from satellites and from instruments, for example, bobbing around in the sea. And the third are the forecasts we have, the GIS-based forecasts we have of future climate. And there's not just one future climate, there's hundreds of future climates, because there's over 40 global climate change models, many different scenarios, and many different time steps and parameters. So we need to be able to, researchers need to be able to bring all these data together to look at what impact these might have on our wildlife species. So for this reason, we work with Nectar and a team of collaborators around the country and internationally to develop the Biodiversity and Climate Change Virtual Laboratory. And we had 4 aims. One was to remove the technical barriers to accessing biodiversity and climate change modelling. This is not because our researchers are stupid. They're actually very clever. They're very good at mathematics. They quite like writing R code. But there are a lot of barriers to bringing data from these various silos together that I was referring to. We want to raise the standard of species distribution modelling, because we need very robust models in order for the information to be taken seriously and used in the real world. We wanted to simplify the access and visualization of these disparate data sets and provide training, especially for early career researchers. And I'm going to give you a case study of 2 species, 2 Australian species, leadbeater's possum, arguably one of the cutest animals on Earth, big baby eyes, and its habitat, the mountain ash, Eucalyptus regnans, which, as you can see from the person there, is actually the world's tallest flowering plant. And there are 2 big threats to the little leadbeater's existence. One is a lot of people are trying to kill it by turning its tree into a cardboard box, right? The other threat is climate change. How is the climate change going to affect that animal's habitat? So I think this is where we go to a video of the research users interface of the VL. So the VL user interface enables the user, the researcher, to quickly search and find the climatic environmental data that it needs for the modelling, to find and discover the biological data. This might come from a repository in Australia. It might come from a repository in Europe, a herbarium there, for example. Researchers can upload their own data if they have been doing fieldwork in the Amazon or the Congo and have some field data of their own. Which is uploading now very quickly. And then you can run different kinds of experiments. Here we're looking at a suite of different kinds of statistical distribution modelling experiments using advanced regression techniques. And when ready, the experiment can be run. You get all the kind of visualizations of the normal diagnostics you get, for example, in this case, from a regression model. And of course, you can get the R script that's generated by the interface if you so wish, and you can look at the results and compare multi-model runs, etc. You can then take that model of current climate and project it into the future. We have access, as I said, to many, many different future climate projections. And here's what we end up with after we do that little exercise. On the top is the current predicted distribution as a function of climate for mountain ash, the home of the mountain pygmy possum. At the bottom is where the pygmy possum current distribution is. And then in the middle where they will be by 2075, and then over on the right-hand side, the difference between the two. And this is what we're looking at. This is Southeast Australia, which is just south-west of where we are in Sydney, down towards Melbourne Way. The red is mountain ash, the blue is leadbeater's possum, and the black is where they overlap, which is, of course, where the animal can actually exist. And what the modelling is telling us is that by 2075, the area of overlap shrinks. So unfortunately, climate change is not a good news story for leadbeater's possum. So how does this all work? Well, the user, of course, doesn't see anything that's in the middle. That's the system. On the right-hand side is the external data. So the user is importing or exporting data from our external data holders through a web API. Is designing the experiment in the system, creates a job file. It gets sent to the virtual machine bank. Next has a cloud of about 30,000 cores. The data is fetched, the script is run, the output is created. So using web and Swift APIs, the data information is transferred from the user to the system to the external data and back again. There's always a backup in the next cloud, and there's short-term job files held in the BCC local database. And this is an iterative process. You don't want to run the experiment once, you want to run it multiple times in order to get a refined model, and eventually you want to share that with the world. So all that the user sees is the left-hand column. It's like a very sophisticated app, if you like. And the good news is, before I finish, that you don't have to be a researcher. Anyone here in this room or anyone anywhere in the world can go to bccvl.org, register, and explore how your favourite species might change as a function of future climate. Thank you.
Thank you, Brendan, for that brilliant example of how collaborative infrastructure has enabled researchers to work together. You might be able to sense as well that that same collaborative idea is moving towards social computing. Up next, our example will show you how OpenStack and high-performance computing is coming together. Gary Egan is a director of Monash Biomedical Imaging, and he's up next. Thanks.
Ancient Egyptians sucked it out of the noses of their dead and then discarded it. Aristotle thought it was a radiator for cooling the blood. But by the end of the Middle Ages, the brain had won respect. No longer spurned as mere cranial stuffing, the brain was recognised as the seat of cognition, key to bodily function, a thing of intrigue, even beauty. In the 18th and 19th century, findings came thick and fast. Electricity's role in nerve function was spotted by Luigi Galvani, inspiring in a roundabout way Mary Shelley's Frankenstein. Louis Victor Le Bonnier helped show that different parts of the brain had different functions when he lost his ability to speak, but none of his other faculties, enabling Paul Broca to map brain areas that made speech possible. Santiago Ramon y Cajal showed that each spider-like brain cell was separate, not fused to its neighbour. That was key to understanding plasticity, and therefore the brain's ability to learn, remember, and recover. Come the 20th century, another patient, Henry Molaison, taught us about memory by losing his own on the operating table. The removal of parts of his brain to treat seizures left Melason unable to remember new events, but still able to learn new physical skills, and allowed Brenda Milner to deduce that there are different types of memory located in different parts of the brain.
G'day. My name's Gary Egan. I'm the Director of the Australian Research Council Centre of Excellence for Integrative Brain Function, and I'd like to share with you today some of the research that we're doing using the OpenStack tools. Nearly 50 years ago, researchers started building the first brain imaging scanners, and you see here a couple of photos from back in the early 70s. The challenge then was to just look inside the living human brain. About 30 years ago, the first images were taken of seeing people do mental tasks, seeing things, hearing things, thinking about things and doing work. And so our challenge has been to map both the structure of the human brain and the functions, and relate the functions to the microscopic detail of the brain that was first discovered by Ramon Cajal. So this challenge is of great interest, and we also look at outliers like Homer Simpson, and we're very interested in the variability across all of us in how our different brains work and function.
Today, we have brain imaging technologies capable of eavesdropping on the ebbs and flows of brain activity from second to second, over distances just the breadth of a few human hairs, without harming a single brain cell. There are techniques like optogenetics that use light to control living brain cells, and transcranial magnetic stimulation that can speak to the brain in its own special language, rousing cells to fire or to rest, to meld into fresh circuits or go their separate ways. And all of this is coupled to insanely powerful computers capable of crunching the torrents of new brain data. International teams of scientists are jumping at the opportunity to use these tools to find out more about the brain. At the Human Connectome Project, they are mapping the brain's connections and relating those wiring diagrams back to each person's cognitive abilities, personality and genetics. At the European Union's Human Brain Project, they are simulating the brain in a computer, arguably the only way to understand such a complex beast. At the US Brain Initiative, they are developing novel neurotechnologies to explore how brain cells and circuits interact in time and space. And at the Australian Research Council Centre of Excellence for Integrative Brain Function, we are working at how the brain interacts with the world, how it shifts attention to the things that matter, predicts what might happen next, and makes decisions, continuously, subconsciously, and at breakneck speed.
The Centre of Excellence is based at Monash University in Melbourne, and there at that facility we have now a wide range of brain imaging technologies, as you can see in this slide, measuring the microstructural connectivity, as well as maps of function, and most recently, metabolism. We also use the massive supercomputing system there at Monash to both process these very large data sets and also to visualize the incredible complexity of the brain in 3D immersive reality environments. So today, we're able to map dynamically brain function, as you see in this video, which is data from a real experiment we conducted a few years ago, where firstly we mapped the structure, as you see in this case, with different sections through the brain. We then ask individuals to do tasks inside the scanner, and we can see the flush of neural activity that occurs at the onset of the task. Throughout the task, there's continued activity, and then at the end, there's another flush when you change your motor activity. So this is incredibly exciting for us. It's enormously great fun, and looking to the future, we actually now have the next generation of brain scanners which are becoming available. And as is the case for the square kilometre array and the large telescopes, as we peer further and further into the brain, we need to increase the resolution of our scanners. So recently there's been the development of the next generation of ultra-high field MRI scanners, and you see in this little cine loop some of the brain sections through the back of the head. This is actually the occipital lobe where the visual processing occurs, and underneath it the cerebellum. And we can now almost nearly see individual neurons in living people's brains. So that's phenomenally exciting. Monash University is located in Melbourne, and the Australian Synchrotron is also located at the Monash campus. And I wanted to finally share with you some of the incredible, exciting data from the synchrotron beamlines. This facility uses the characterization virtual laboratory, which is built on the Nectar stack, and our research work, particularly using imaging, would be impossible without that underlying computing infrastructure. So here's an image of a rodent. It's not as pretty an animal as Brendan's that we heard about earlier. It's a rat. And in this research, we're using synchrotron phase contrast X-ray imaging to be able to look not just at the whole animal, but in detail inside the animal. And this is an amazing new technique for 3D volumetric ultra-high resolution CT scanning. So we're looking at structure here in this video, but in fact, when you do it very fast with the synchrotron's high flux of X-rays, you can actually infer function by looking at dynamic structural changes, as in the case of respiration in the lungs.
Brain science is entering a new era that will transform the ways we learn, play and work, even our very sense of what it means to be human. To share that journey of discovery, to contemplate its ethical and social issues, and to co-create the future together, the Centre for Integrated Brain Function runs the Brain Dialogue, a program of events, online discussions, citizen juries and participatory science. Visit us at www.cibf.edu.au.
So thanks to OpenStack, and thank you for your attention.
Thank you very much to these researchers who took time out of their busy schedule to come talk to us. We really appreciate it. We also want to give a shout out to the Science Working Group who just updated their book about HPC. So a big shout out to the Science Working Group. They'll be meeting this week. There'll be quite a few different sessions. If you're interested in hearing more about this research that's happening, you can also check out the University and Research track on the schedule.
Last but not least, please do not forget to have a good time with OpenStack. Thank you.